The future of genomic medicine depends on AI. Do you know why? So we have entered a new era where AI is transforming every aspect of our life, and that includes health and especially genomics. Now, machine learning or AI has been around for quite a while, but what is a game changer now is the amount of data and the amount of compute that is available to really crunch through the information and get the insights out of the available information that we have. So with that, it opens up a whole new area for us to understand ourselves, our genomes, and bring that information back to health and health research. AI and machine learning need to learn from data. With genomic data being the 3 billion letters in your human genome, that is a lot of information about a sample point. And typically in machine learning, the rule of thumb is that you need to have as many samples as you have features. So in our case, that would be 3 million. Now clearly we cannot have 3 million samples now available from every individual on the planet. But we've developed machine learning algorithms and can cope with this disparity between the amount of samples and the amount of features that we have available. Specifically, there's a random forest approach, which is rumored to be resistant to overfitting. Obviously, no machine learning method can be resistant to overfitting, but it is more stable and it's more capable of dealing with this disparity between the amount of samples and the amount of features. In addition, it is also explainable, which means that the features that will come up as being important, that the machine learning method has identified as being important, can be explained by putting a number on it, and therefore clinicians and researchers will be able to judge whether the result that the machine learning method has come up with is correct or not. So AI and machine learning will help specifically in early disease detection and drug discovery by looking at this amount of data, and rather than traditionally eyeballing or applying statistical approaches, machine learning can look at the whole data in one go and can thereby bring the interactions that might be hidden inside the genome, bring that to the forefront and identify what is actually happening. So machine learning is not a silver bullet. Machine learning is still a methodology, and a methodology needs a design. And specifically in AI, it is seen as a dark art to create or pick the right features and pick the right hyperparameters that govern how the machine learning method works. So the challenge is how to ensure that the data can still be analyzed while being kept secure and safe and under the control of the individual. This can be done with trusted research environments, which are computational vaults, where the data is logged in, the individual has full control of what happened to that data, yet research and analysis can happen on the data to identify disease risks going forward. By embracing interdisciplinary research, bringing industry and government together, it holds the potential to unlock the full potential of the human genome and have research outcome and healthcare improvements for generations to come.